Let's look at some problems where we simplify formulas. So the perimeter of a rectangle is twice the length plus twice the width. Here, we want to find the length of a rectangular lot if the width is 65 feet and the perimeter is 330 feet. So first, we'll plug in the given information. So the perimeter is 330, and that's equal twice the length plus twice the width of 65. It's usually a good idea to use parentheses when you substitute into a formula, especially with negative signs and fractions and exponents. So cleaning this up a little bit, we can double 65, so that's going to give us 130. And copy down the rest. To solve for L, we'll get rid of the 130 first. Since it's added, we'll subtract 130. The reason there is if we add 130 and subtract 130, that's like putting a 0 there. So minus 130 on this side. And so we get 0, 0, 200 equals twice the length. And then here we'll divide by 2. And now we can see that the length ought to be 100. It's usually a good idea to check something like this. So I think the length is 100. So checking with the perimeter formula, if I double that 100 and add to that double the width of 65, that's going to give me 200 plus 130, which is 330, which is what the perimeter is supposed to be. So check. Moving on. Here we want to solve for y in the given equation. So we're going to isolate that y right there. So we want to get the things furthest away from it first. So what we'll do first here is subtract 3x because it's being added on that side. We'll have to subtract on the other side. So 3x minus 3x is 0. 0 plus something is just itself. So I have 5y left behind. 15 and negative 3x aren't like terms, so I have to leave it as 15 minus 3x. Next, I want to break that multiplication there to get the y by itself. So I'll divide by 5, and both sides need to be divided by 5. Now, a number divided by itself is 1, and multiplying by 1 is kind of boring. So I have 1y on the left side. On the right side, that's a fine way to leave the answer. So that is one possible answer right here. Although you could view it as both the 15 and the minus 3x are being divided by 5. Which is like the reverse of subtracting fractions. If you have a common denominator, you keep that denominator and combine the numerators. And so I could then say y is equal to 5 goes into 15 3 times minus 3/5 x. So this would be another way I could state the answer here. Okay. Usually, if it's a testing situation, you want to pick one or the other. And so I would probably stop at that one right there because it's less work, less room for error. So either way, I've solved for y. Let's try another. Here we want to solve for x. Well, this is going to be a bit easier because there's just one x there. So to get rid of a subtraction, I'm going to add 5y to each side. So on the left, if I subtract 5y and then add it, that's a 0. X plus 0 is just x. On the other side, since the 3 doesn't have a y, they're not like terms. So I could say that's negative 3 plus 5y. And I've solved for x. So my answer would be that right there. Often we state the y first, so an alternative answer here would be 5y minus 3. But that's a great place to stop if that's what you wrote first. Let's do another. Solving for y. In this case, to get the y alone, I'm going to remove the outer stuff first, so that since I've added a positive 2x, I'm going to have to subtract the 2x to the other side. 2x minus 2x is 0. 0 plus 10y is 10y. These terms on the other side are not like, so that's just 11 minus 2x. Next, to get y alone, I have to break that multiplication by dividing by the same number, 10, and that whole side gets divided by 10. On this side, a number divided by itself is 1. 1 times y is y. So that's the only time you can cancel, if you have a multiplication and a division by the same exact number. On the other side, I'm just going to leave it as 11 minus 2x over 10. If you have to enter this into an online computer system, then you would have to put the numerator in parentheses and then divide by 10. So this is the way I would write the answer if I was using an online homework system. And that's it for now. I hope you enjoyed this episode of Playing with Formulas. Bye-bye.